The consumer technology sector is aggressively shifting away from the screens we hold in our hands. The industry is actively replacing pole-based handhelds with continuous, body-worn sensory nodes that observe the physical environment in real time. In fall 2026, Google is accelerating this transition with the launch of its Android XR intelligent eyewear platform. This hardware release is a highly targeted maneuver designed to break Meta's absolute grip on the wearable market, where Meta currently holds an 82% market share with its Ray-Ban smart glasses. Google attempted this exact pivot in 2013 with Google Glass. That product was pulled from the market just months after its UK release. Consumers rejected the high price tag and the incredibly obvious asymmetrical camera prism that broadcasted its surveillance capabilities to everyone in the room. To solve that hardware rejection, technology companies have completely overhauled their aesthetic strategy. Google and Meta have partnered with established luxury eyewear retailers, brands like Warby Parker, Gentle Monster, and EssilorLuxottica, to make the hardware look entirely benign. Inside the thick acetate frames of these classic designs are dual outward-facing cameras, spatial orientation sensors, and multi-channel microphone arrays. These devices function as edge node telemetry endpoints. The technology industry is embedding a decentralized sensor network directly into fashion accessories. The consumer marketing campaigns pitch these glasses as the ultimate convenience, a secure, hands-free assistant offering all-day help powered by agentic AI. The economic reality of the hardware tells a different story. These platforms heavily subsidize the retail cost of the glasses to turn their consumer base into millions of unpaid physical world data gatherers. Google specifically designed its platform to be cross-compatible with both Android and Apple's iOS devices. Bypassing mobile ecosystem restrictions allows them to maximize the hardware's data collection footprint across all demographics. This physical network is already massive. Meta reports having sold 7 million pairs of its Ray-Bans into the consumer market. This deployment creates an immediate, severe privacy tension. A bystander walking down the street has no control over what happens to their image, their voice, or their private data the moment it enters an AI-enabled lens. By placing millions of these sensors in public, Meta and Google are shifting the data economy from digital indexing to the mapping of physical reality. This equation defines neural scaling laws, the mathematical bedrock of AI development. It dictates a strict rule. To increase the capabilities of an AI model, the computing power and the volume of training data, represented here by the variable d, must scale proportionally. The entire sector has collided with a structural crisis known as the chinchilla scaling bottleneck. The global AI industry has largely exhausted the high-quality, publicly available text data on the internet. The text databases have been consumed. To maintain the trajectory of model performance, developers must look beyond text. Scaling frontier models requires the ingestion of high-fidelity, real-world, multimodal data to satisfy these mathematical constraints. They cannot rely on third-person, exocentric video, like YouTube clips or Hollywood movies. They require egocentric or first-person, spatial data that accurately maps how human beings navigate and focus their attention in three-dimensional environments. This 3D wireframe illustrates how Meta captures this data through its foundational EgoXO 4D research initiative. The hardware records 7-channel time-aligned audio to map the spatial acoustics of the room. High-frequency inertial measurement units record the physical micro-movements of the wearer's head. Infrared gaze tracking sensors map exact focal points to digitize human attention, while external cameras generate real-time 3D point clouds of the physical architecture. Smart glasses are the only viable hardware capable of feeding this multimodal model. They are the structural bridge necessary to ground AI in physical reality. Google and Meta compete aggressively for this physical data, but deploy distinctly different hardware philosophies. Google is executing a collaborative open ecosystem strategy. They provide the Android XR operating system, relying on Samsung hardware manufacturing and Qualcomm silicon to build the actual devices. Google's initial release is an audio-first, screen-free pipeline. It integrates heavily with the Gemini 4 multimodal architecture, allowing the AI to continuously process the environment and execute multi-step commercial transactions in the background. Meta operates a vertically integrated, tightly coupled proprietary ecosystem. Their premium hardware features a 600-pixel monocular display built directly into the right lens. Meta's solution to this social friction of operating hardware in public is the Meta Neural Band. This wristband utilizes electromyography, or EMG, sensors. This schematic details the interface difference. While Google relies on voice, the Meta Band reads the subtle muscle signals firing through the user's wrist. This allows for completely silent navigation of the glasses display. A user can record, select, and interact with the AI without ever speaking a command or visibly tapping the frame. Both designs are optimized for the exact same function, removing the social friction of wearable computing to ensure a continuous, uninhibited flow of real-world data. The central defense offered by hardware manufacturers is that local photo, video, and audio recordings remain isolated and secure on the user's mobile device. The physical specifications of the hardware invalidate this claim. The chips in slim eyewear frames cannot execute complex computer vision or advanced multimodal tasks locally. When a user asks an AI agent to analyze the visual scene in front of them or translate a spoken conversation, the raw sensory data is immediately exfiltrated to centralized cloud servers for processing. Under Google Gemini's consumer terms of service, even with tracking disabled, interaction data is temporarily retained. Selected prompts, audio recordings, and media are disconnected from the primary account, stored for 3 years, and routed to human reviewers to train future machine learning models. Google explicitly prohibits generative AI training and human review for its Workspace enterprise clients. The company possesses the capability to build robust privacy boundaries, but actively chooses not to apply them to the consumer hardware ecosystem. The severe vulnerabilities in this human review pipeline were exposed in early 2026, centering on a third-party moderation firm operating in Nairobi, Kenya. Meta outsourced its AI training data review to this facility, tasking contractors with labeling raw, first-person video feeds captured directly from users wearing Meta smart glasses. The automated algorithms designed to blur faces consistently failed in standard low-light environments. Foreign contractors were exposed to high-definition footage of users undressing, utilizing bathrooms, and displaying sensitive financial credentials. The device on the user's face operates as an extraction apparatus, systematically converting deeply intimate human experiences into proprietary corporate training assets. The only physical mechanism protecting bystanders from covert recording is a small LED indicator light built into the frame of the glasses. Meta deployed an ambient light sensor adjacent to this LED. If the software detects that a user has taped over the light to block it, the camera is programmatically disabled on startup. A dedicated gray market has easily bypassed this defense, selling custom-engineered micro-perforated stickers for $18. These stickers diffuse the bright LED, rendering it invisible to bystanders, allowing just enough ambient light to pass through the perforations to satisfy the sensor's software check. A second, more severe architectural flaw exists in the firmware itself, the startup check race condition. This timeline illustrates the flaw. The software only pulls the light sensor at the exact millisecond the recording initiates. A user simply starts the recording, immediately covers the light sensor with their hand, and the device continues to capture high-definition video indefinitely. All the hardware safeguards are trivially bypassed. Any individual in a physical space is entirely stripped of their ability to verify if they are being actively recorded. When active recording devices become visually indistinguishable from standard prescription eyeglasses, public anonymity ceases to exist. This dynamic creates a panopticon, a sociological state where individuals continuously modify their behavior because they must assume they are being watched at any given moment, even if they cannot confirm it. The result is a profound chilling effect on public discourse. People withdraw from open, spontaneous engagement when they suspect every casual interaction, every awkward glance or conversation is being captured and indexed by an AI model. This hardware is already fueling social media trends, where bystanders are covertly recorded, tracked, and publicly humiliated without their consent. The real-world predation risk was explicitly quantified by students at Harvard University, utilizing Meta Ray-Bans. The students linked the live video stream from the glasses directly into external, public facial recognition search engines. By looking at a stranger on a subway, the wearer could instantly pull up the target's name, home address, and family relatives on their phone. Despite these recurring scandals, sales for smart glasses continue to rise. This indicates that for millions of consumers, the daily utility of the hardware has begun to outweigh the abstract loss of privacy. The threat profile extends far beyond public streets. It introduces catastrophic liability directly into secure corporate, retail, and healthcare environments. A compromised, visually benign endpoint allows a contractor to record proprietary source code, financial documents, or physical assembly lines completely undetected. Current legal frameworks are unequipped to handle this hardware class. Traditional privacy laws regarding photography rely on the obvious, physical gesture of a person holding up a smartphone. In action, smart glasses circumvent entirely. If a health worker or retail employee inadvertently records a patient's voice print or a customer's facial geometry using intelligent eyewear, the host organization faces severe financial exposure under strict biometric compliance laws like BIPA, GDPR, and HIPAA. Corporate risk officers face an immediate mandate. Organizations must establish absolute, zero-tolerance ban zones for wearable technology, treating any pair of eyeglasses as an active intelligence threat until physically verified. Policymakers must move past voluntary guidelines. The hardware requires preemptive statutory bans on consumer facial recognition and hard legal mandates for tamper-proof recording indicators. Until rigid boundaries are established, the physical world remains fully enclosed, functioning as a non-consensual extraction zone for the technology sector's final data grab.